Hello everyone, my name is ZHILIN and my thesis topic is development of an effective sample preparation procedure for peanut allergen detection in prepackaged foods. Peanut allergy has been a widely concerned problem over the world with the increasing prevalence. Food label plays a crucial part in this way by offering sufficient information on the food ingredients to patients. And in this area, ELISA is the most common method in the area of the peanut allergen determination. However, processing may alter the properties of proteins, and extraction conditions also have a great influence on the yield of proteins. This will lead to inconsistent results and lower the sensitivity and the accuracy of the ELISAs. As a result, people with allergies are at risk. So, in order to improve the consistency of the ELISA results, we study from 2 points. The first one is to use a more thermally stable detection target, RH2. RH2 is the heat-stable protein in peanut allergen, which means that using it as a target protein can decrease the influence from food processing. The second one is to improve the efficiency of protein extraction. Protein extraction is the crucial step for sample preparation, especially for the choice of the extraction buffers. Recently, a novel extraction technique has been used to peanut protein extraction by adding SDS and 2Ne as a surfactant and a denaturing respectively to decrease the influence by thermal processing. After processing, the peanut protein will be denatured and become insoluble. When applying this additive, 2Ne will destroy the disulfide bond between the protein molecules and make the peptide become lighter. That will increase the connection between the detection antibody and the peanut allergen. And SDS will increase the solubility of the protein, so the result of the design will be more consistent. However, this novel method based on total protein is necessary to study if it is suitable for the ELISA based on RH2. Before improving the extraction buffer, we have to create our own ELISA standard curve based on the RH2. Through protein extraction, PSA methods, SDS PAGE, antibody purification, ELISA titration, and ELISA standard curve, a set of ELISA detection methods with RH2 as a target protein was established, and it was compared with the total protein ELISA. And then we go back to the stage of peanut extraction. Peanut protein was extracted by buffers with additive, sodium sulfate, and 2Ne. The additives in the extraction buffer may impact the result of ELISA. In order to reduce the influence, the extracted buffer was diluted with 1% PSA in PBS buffer, and then the diluted buffer were used to create a standard curve to compare the difference between them. As for results, C20, C50, and C80 were involved to compare peanut ELISA. These parameters are the concentration of peanut protein produced from the percentage of color development at 20, 50, and 80 of the maximum absorbance. As for the table, the first and the second antibody targets on RH2, and the third one use total protein as target. By comparing SHIKAI's or ELISA method, it's obvious that RH612 has a lower C20 and a lower C50. In addition, table shows that it has the lowest band value and the highest maximum absorbance value, which is the ideal detection antibody. As for the influence of additives, as can be seen from the fridge, with the increase of the dilution factor, the different curves are closer to the standard curve, which means that the higher the dilution, the smaller the impact on the final results. The result in the table also affirms this opinion. With increasing dilution factor, C50 and C20 decrease and approach the value in the standard curve. However, with the increase of dilution, later one is closer to standard curve than the first one. This shows that compared with 2Ne as additives in the extraction buffer, sodium sulfate may have less impact on the final result and be more suitable for ELISA. In this study, RH2 ELISA was established, which show better C20 and C50 than the total protein ELISA. In addition, as for extraction buffers, the results show that 2Ne and sodium sulfate has a great impact on the final results, and the 1 in 20 dilution show better results than the others. However, the effect of the heat sample on these two ELISA methods hasn't been studied. Standard curve of total protein and RH2 should be established, and then the differences between them should be analyzed carefully by using heated sample. And more experiments should focus on finding new additives with less impact. Last day study only studied the whole peanut, but peanut proteins may fall into the other product in production line. Therefore, model food and spice samples should be set up to validate the method by calculating the recovery using ELISA based on RH2. Thank you.